biologist with the USGS Midwest Climate Adaptation Center, or Midwest CASC. Holly's research aims to understand conditions to support self-sustaining inland fish communities in a changing climate across a range of scales. Her work is collaborative and seeks to inform the conservation of inland fisheries by working directly with partners to address areas of management concern and develop adaptation strategies. Holly recently got her PhD from the University of Wisconsin-Madison and an MS from the University of Toledo and the BS from McGill University. And so you've been with CASC since 2020. So with that, I'll let Holly take over, and I'll join Zoom too, just in case like anyone has any
questions or issues. Perfect. Yeah, let me know. Thank you all for coming, and thanks everybody for joining online. And thank you for having me here. I'm excited to be able to be here in person. I have a wedding here in town tonight, so it was really good timing to be able to join in person. And I'm excited to be on the U of M campus. So as Olivia mentioned, I am a research fish biologist with the Midwest CASC, which our headquarters are hosted out of U of M here, so out of the Institute on the Environment, just down the road, I believe. And so we were just established about a year ago as a Midwest CASC. And so we're just starting to build our program and establish our relationships with our consortium partners and our host at the University of Minnesota. So today I'm excited to kind of talk about the start of my research program, as well as introduce myself to folks here at the Conservation Sciences Department and think about kind of future avenues of research that we can tackle together. So my focus today is going to be highlighting 3 different projects that span a range of research topics focused on adapting diverse inland fisheries in a changing climate. So inland fisheries are ecosystem service hotspots. They provide a disproportionate level of ecosystem services across the globe, from cultural benefits where folks may not be willing to necessarily go out and go for a long hike out in the woods. I mean, many of us would probably in this department, but I think the general public may not, but lots of folks may be willing to go and sit on a frozen lake to spend time with each other and fish for recreationally or food or for different motivations. So it provides, inland fisheries provide a really important connection to nature. Ecologically, inland fisheries are a key driver of change. They provide a key source of subsistence for certain communities and provide economic and employment benefits around the globe. And I think we're just starting to understand these, especially the economic, employment, and subsistence benefits on a global scale for inland fisheries. But inland waters are transforming and susceptible to many influences because of their tight human land-water linkages. So from different changes, from habitat changes, habitat degradation, climate change, global drivers causing changes in species assemblage shifts where cool water species, cold water species are declining while warm water species increase, causing changes in novel species interactions, as well as invasive species in spiny water flea shown here. And then of course, these fisheries exist within kind of some in more dominant harvest-oriented fisheries, and so that also drives change. These inland fisheries support multiple diverse user groups from especially in the Midwest and upper Midwest, where we're sitting today, where indigenous communities, angling communities, and commercial fishers are all reliant and dependent on these fisheries. And these users have different and sometimes competing needs and desires. So when we're thinking about managing for change, we need to understand how these different user groups are understanding these different fisheries. So today I'm going to highlight 3 different projects that are at different stages of their work and dive into kind of the progress and highlight those. And first, I'm going to focus on a project that's just kind of at the early stages. Many folks here at Minnesota are collaborators on this project, focusing on walleye fisheries bright spots in a changing climate. And then talk a little bit about a project that's been going on for a bit over a year, focused on tribal perspectives on NAME, lake sturgeon in a changing climate. And then another project that's a bit more global, focused on expanding community resiliency in the Mekong River Basin. That has been a few years in the making, but I've just completed the fieldwork portion. So thinking about kind of the synthesis side of that. So I want to highlight here, this is not going to be a very data heavy talk. This is going to be a talk about kind of different approaches to understanding inland fisheries change and adaptation options, and kind of how we can think about managing for this change. So I've done some more quantitative work, and that I would be happy to chat about, but that's not going to be the focus today. So today, to first start chatting about the Walleye Fisheries Bright Spots project, this is a highly collaborative project. All of the projects I'm going to talk about today are very, very collaborative. But the collaborators as part of this project include USGS and Midwest Cask, as well as the National Cask, University of Minnesota folks here. Chris is on this project. Gretchen Hansen's lab, Jenna. As well as some folks out of University of Wisconsin-Stevens Point, folks at the Center for Limnology at University of Wisconsin, Wisconsin DNR, and folks at the Great Lakes Indian Fish and Wildlife Commission. So a little bit of background: walleye are a highly valuable local inland fishery. They provide lots of cultural, economic, and ecological benefits to folks around their native range in the north central North America. And are a multi-use fishery where they're highly important for angling communities as well as indigenous communities. But walleye recruitment and production has declined especially over the past 10 to 15 years. I'm showing these trends here for age 0 abundance in the ceded territory, so that northern third of Wisconsin, where these trends have really been emphasized. And so some of the drivers of this walleye change come from these global drivers of climate change, where lake temperatures and air temperatures are warming, water levels are shifting, winter conditions are also changing, so resulting in lake ice and conditions, resulting in kind of internal lake habitat changes, where shifts in lake stratification, shifts in lake water clarity, resulting in kind of novel conditions for invasive species, as well as shifts in what's called thermal optical habitat area, which is a important driver of optimality for walleye. Walleye are a cool water fish and have a thermal characteristic requirement, but they also have a specific optical requirement where they prefer low light conditions. So with climate change and with these shifting global drivers, we've also observed some lake clarity changes occurring. But of course, global drivers like climate change and lake habitat shifts do not just affect cool water species like walleye. At the same time that these declines are occurring, warm water species have been increasing, causing these changes in species assemblages and potentially resulting in increased predation and competition between warm water species and cool water species like walleye. And walleye exist within this pretty heavily harvest-dominated fishery, both mainly dominated by angling harvest. So all of these factors kind of come together in different ways in different spaces to result in drive walleye declines. But what about where walleye are doing well? So we have much of our research focus has been on drivers of walleye decline and understanding why walleye have been underperforming and declining, which is certainly important to understand. But now, as we think about adapting to this change, we're not necessarily going to be on a management front able to change climate drivers. So thinking about adaptation options, it may be beneficial to think about identifying these bright spots or where walleye are doing well at overperforming, given all of these changes and this complex of factors causing declines. So that's kind of the focus of this project. So for this project, we're focusing on the interacting drivers of walleye fisheries bright spots, and bright spots here defined as a successful fishery. And I'll jump into what a successful fishery is in I think our fourth objective here, because that is certainly context dependent and dependent on who you're talking to. So to break it out, for our first part of this project, we're focusing on a whole lake Centricidae removal, which we've are leveraging from the past 5 years. That was ongoing. And for 5 years, we removed almost 300,000 fish from a lake, warm water fishes, to see how that affected walleye recruitment. And now we're continuing that work to evaluate the role of bass and sunfish predation and our competition in regulating walleye recruitment. So we've stopped after 5 years of warm water species removal, we've stopped the removals. And now we're trying to determine with some standardized monitoring if walleye demographics shift in response to these reductions in predation and competition, how the population dynamics of bass and sunfishes and other cool water species like yellow perch shift in response to these fish removals, and then how shifting species assemblages alter food web dynamics and species-specific biomass and production. For our second portion, we are focusing on walleye behavioral response to that thermal optical habitat area. So as I talked about a little bit, thermal optical habitat area is this combination of optimal temperature and light conditions for walleye in a lake in a given year. Gretchen Hansen here at Minnesota has done tons of work, and her lab has done tons of work on this. So they're certainly the expert, and they're part of the leadership on this portion of the project. So I'll send you to them if you have more questions. But with this, we're putting in tags into adult walleye and juvenile walleye to understand, to track their movement within lakes, to see if they actually use the model predicted thermal optical habitat area that we would expect them to. And then see how their thermal ecology and bioenergetics vary among lakes that differ in their thermal optical habitat area. And then a bit of methodological comparison there. The third component of this project focuses on a synthesis of adaptive management experiments. I'll shout out Chris here, who is part of this portion of the project. Where we're focusing on synthesizing fisheries management experiments in the search for bright spots. So across the walleye management landscape in the US at least, there have been tons of management rehabilitation efforts that have been done, but little synthesis to kind of understand how effective those efforts have been and whether we can reveal any ecological mechanisms through those approaches. And so some of those efforts have included kind of experiments involving stocking regimes, regulation changes, as well as some targeted species removal. So I mentioned the targeted species removal about removal of warm water species like bass and sunfishes, but others have removed warm water species like bullhead. So we're going to try to bring all that information together, working with managers to understand how they view the efficacy of those management restoration approaches. And then finally, the fourth is to analyze bright spots in a comparative and theoretical approach, and analyze lake characteristics, management strategies, and population rates predictive of bright spots in the upper Midwest. So trying to understand which factors are associated with bright walleye populations for different groups. So for example, for a angling management agency, a bright walleye fishery may be one that is provides adult fish 2 to 5 years from now, but for a tribal management agency, they are managing for 7 to 10 generations from now, so of human generations from now. And so understanding how you can balance different objectives of success within management agencies, and therefore work towards building that into modeling approaches and metrics of success is something that we're really thinking about here. And then incorporating that second component of our understanding of thermal optical habitat use and interacting with those other variables to influence walleye abundance. And then again, yeah, thinking about how all these metrics of fishery success are related, and especially across these different management groups. Okay, so that was the kind of first project that's just at the starting stages, and we're really excited. The fieldwork just began this summer on that, and then we're just kind of starting to dig into the synthesis portion. And we have a few years left on that. So if folks have any questions, happy to discuss more. Okay, the second project I'm going to highlight here is a project that's in collaboration with the Great Lakes Indian Fish and Wildlife Commission. And it certainly this would not be possible without them. And I also want to highlight at the Midwest CASC, we are fortunate enough to have a tribal resilience liaison, Sarah Smith, working with us, who is hosted out of College Menominee Nation, who was a big part of her role is to facilitate research, or for me at least, my research and work with tribal nations. And so she is a really key person in working on this type of project. And it would not be possible without Bliffwick and Sarah's work. So to give you a bit of background on Nome, or lake sturgeon in the upper Midwest, this map here shows the gray as of 2016 is the historical range of lake sturgeon. And then the blue is their present range. So very, very much more condensed, and I'll go into those declines in a second. But Nome have a really strong subsistence, cultural, and spiritual relationships for many of the tribes in the upper Midwest. And are native to and threatened in 20 US states and 7 Canadian provinces. But relative to kind of some other, what I would characterize as probably game fish species like walleye, have received a lot less research attention. But Nome are a cool water species, and they're very, very long lived. They're late maturing. So for females, it takes almost 25 years for them to reach maturity and to spawn, and about 10 years for males. And they're patadromous. So they spawn, most live in lakes during most of their life history, but then they need to spawn in the spring on these gravel shoals and in stream rapids. So they need flowing water to do so. And their spawning triggers are changes in water temperature, water level, and flows. So they're very tied to seasonal changes and very tied to changes in water temperature, water and water flows. And so Nome have really declined severely throughout their range. And so in the upper Midwest, and these mass declines and extirpations have occurred following European settlement, especially due to extreme overharvest, as well as habitat fragmentation and degradation. So dams. So like I said, lake sturgeon are patadromous. They need a certain length of river to spawn. And so with the kind of expansion of Europeans and in combination with overharvest, then dams have been built and kind of blocked off some significant habitat area. So the combination of these declines and the unique life history, so the late maturing characteristic of lake sturgeon, makes them really sensitive to environmental impacts and thinking about climate change when we're looking towards the future. So Nome and climate change. So given the changes in climate, there's considerable concern, especially with tribal nations, about Nome. So currently many tribes do not harvest Nome. Basically not populations are not at a level where you can necessarily harvest them. So it's not as much of a subsistence issue as although they would like to, in a perfect world, get Nome up to populations up to a level where you could harvest them again, but are certainly more concerned about conservation and just having these long-lived beings present in their natural habitats once again. And so, given the changes in climate that we're anticipating in the upper Midwest, the shifting precipitation, increasing temperatures, loss of winter, and then the shifting species and invasive species, we're thinking about how all of these factors may impact lake sturgeon. So for this project, we wanted to understand how Nome will be affected by climate change and how they currently are. Folks may be experiencing those changes now, and understand tribal perspectives on current and future management challenges. So to do this, we are having a series of conversations with tribal biologists, natural resource directors, historic preservation officers, and managers, and then conducting a literature synthesis of drivers of Nome fisheries shifts given climate change. And we hope to be able to identify potential climate adaptation options and recommendations, as well as future priority research avenues to then work with these tribal nations on these research avenues. So the conversations, this is an ongoing project we've been working on for about a year. And I think with projects like this that are extremely collaborative and co-produced, the ability to have a long time scale in your project is really where I'm very fortunate in that, because accommodating different folks' schedules and abilities to engage on a project like this, everybody's just doing this kind of in their free time. And so understanding, when folks are able to give their time for a conversation, it requires a lot of flexibility. And so the conversations are ongoing. We've had about 5 conversations at this point. We're only able to do 9 to maintain data and knowledge sovereignty. And so we're including Indigenous representation. We've invited all of these folks, and we're kind of just in the scheduling phase of the rest of them. But includes Indigenous representation from the 1854 Treaty Authority, Bay Mills Indian Community, Gun Lake Tribe, Ho-Chunk Nation, Intertribal Council of Michigan, Keweenaw Bay Tribe, Menominee Indian Tribe of Wisconsin, Red Cliff Band of Lake Superior, and Sault Ste. Marie Tribe. So it kind of spans around the Great Lakes. So what we have learned so far, I'm going to kind of summarize from the first initial about 5 of 9 conversations, as well as the literature synthesis, which is completed. Lessons learned so far, focusing on those climate drivers, regardless of location. Lake sturgeon were sensitive to these variable thermal and hydrologic conditions, and folks have been really emphasizing how they're starting to observe these bottlenecks in early life stages, especially age 0 and age 1s, and are keen to dig into where these fish are going during the day. It's kind of a unknown black box, but then what is kind of happening. So folks are kind of seeing eggs deposited, potentially larvae hatch, but then are not seeing fish recruit to the next juvenile stages. So with higher water temperatures, folks have talked about concerns regarding acute mortality. So of course, with higher water temperatures, that can cause fish die-offs because of increased stress or directly causing mortality, or decreased body condition and just kind of overall reducing the fish population. Increased, big concern folks have talked about is the interplay between higher water temperatures and increased parasites and disease transfer, especially on eggs, and kind of fungus growing on eggs, as well as a specific virus within more adult fish. And then, of course, the increased competition predation with warm water species and invasive species. But then other folks have kind of highlighted a potential positive is this kind of increased growth associated and kind of potential range expansion potential for lake sturgeon, given they are a cold water species and may be currently range limited in some places. The other kind of key concern folks have talked about from a climate perspective is the altered timing and amount of precipitation, potentially leading to a mismatch of spawning cues. So like I said, lake sturgeon are super dependent on water flows, which in the spring is coming from snow runoff or rainfall. And so a lot of folks have talked about kind of protracted or much earlier spawning seasons happening, as well as spawning habitat becoming inaccessible when kind of on the flip side, you don't have enough snow or runoff to create those linkages. And then kind of an overall decline in habitat suitability. And then with these kind of increased, this increased variability in precipitation, folks have talked about the concern about the sedimentation of eggs. So with a flash flood event, you may get lack of habitat accessibility, as well as eggs may just get sedimented and covered in sediment and then washed away and stuff like that and never be able to hatch. The major concern, kind of the key concern many folks come back to in the future is access. The access and kind of that moves in a bunch of different directions. So the access to exercise harvesting rights is a concern. So in some places harvesting is still possible. It's very limited where that is still present. As well as the access to perform management surveys and to continue to understand and build our understanding of these population dynamics and habitat suitability given climate change. And so if a river washes out, given a flash flood in the future because of this variable precipitation, how is a manager supposed to go out there and perform a larval drift tow to, they are unable to do that in the future. And so we may get spottier management surveys. And so this is kind of the key concern folks have kind of come back to. So the information needs folks have really highlighted, some focus on the biotic, really thinking about movement assessments, thinking about where adults spawn, where juveniles go, where young fish, early life history monitoring, where young fish, those age 0, age 1 spend their time, especially during the day. And then thinking about diet and food web studies. So what are the fish eating and is that changing over time? So especially with the kind of increase in invasive species, is that causing a shift in diet such that that's reducing the diet or shifting the diet preferences of lake sturgeon in certain areas and shifting body condition or anything like that. And then some tribal nations have really emphasized the need for increased abiotic variables and more localized data, whether that's temperature data, precipitation data, runoff information, sedimentation information, contaminant information, to really get a handle on a local level, how these changes are going to impact their communities. And then to kind of overall understand how these changes are impacting habitat for lake sturgeon, but I think also kind of fisheries in general and their watersheds and kind of on a more holistic understanding just how habitat is changing. And then broadly thinking about the interactions between the biotic and abiotic. So thinking about spawning and thermal refuge hotspots, whether understanding where fish are spawning and how that's tied to temperature information, how spawning site fidelity is impacted by the shifting climate, whether fish are going back to the same locations despite increasing temperatures and shifting precipitation, or whether fish are adapting and moving around. Folks just don't really know right now. And then the impacts of the shifting phenology on NAME spawning. So as I mentioned, folks have been kind of observing earlier and protracted spawning season. So how is that overall impacting these fish population dynamics? So some folks and some communities have started to implement some adaptation options and others have started to kind of think about what those would look like. One theme is tied to kind of population restoration, focused on jump-starting natural recruitment. And the kind of strategy used there is this capture transfer of adults. So Menominee Nation has done a project in collaboration with Wisconsin DNR, where they have captured and transferred adults from below a dam to above a dam to restore a population and have jump-started natural recruitment that way. But most other projects and foci have been on habitat restoration, where the aims have been on rehabilitating spawning habitat through kind of putting cobble back in streams like that, or increasing riparian habitat, or providing thermal refuge for juveniles and adults in the streams. So these approaches have kind of spanned approaches and ideas have kind of spanned water retention projects, so reconnecting floodplain habitat, which would likely be good nursery habitat for juveniles, reducing non-climate stressors like pollution through riparian buffers, pulsing flows. So for regulated systems that have dams on them and are work with kind of dam operators, folks have tried to coordinate and pulse flows during critical times like low flows and high temps during spawning periods. And then overall, I think an intention has been to reduce and modify barriers if possible, but that presents a lot of political and societal challenges in many instances and is very expensive. Okay. How are we doing on time? Awesome. Okay, so for the final portion, I'm going to talk about a project. I just got back from the fieldwork portion, so it's mostly photos. But this project is focused on expanding community resiliency in the Mekong River Basin. This is a project that was in collaboration with the U.S. Embassy in Bangkok, as well as a civil society organization in the Nong Khai region and some communities in kind of northeast Thailand, focusing on understanding the impacts these communities have been experiencing due to climate change, hydropower development in that region, and land use change, and just really basically documenting impacts, developing recommendations for adaptation options, and has been super informative on multiple fronts. So to give you a bit of background about climate impacts in the Mekong River Basin, the Mekong River is the river highlighted here. It spans 6 countries in Southeast Asia, flowing from China through Myanmar, Vietnam, Laos, Thailand, and Vietnam, and out through Cambodia. Many communities in this river basin are dependent on the river for their livelihoods, but the conditions are really changing due to a variety of factors. This probably 30 to 40 years ago, this region was relatively undeveloped. And within the past 20 to 30 years, hydropower development has just expanded astronomically, mainly in China, and then now in Laos. And then a little bit now in Cambodia and Vietnam. Thailand doesn't have so many main stem dams, but there are a couple on some tributaries, but where the communities in Thailand and all kind of throughout this region are just being severely impacted. And then on top of that hydropower development, there's just a lot of other change happening, whether that's climate change or land use change, because these communities, especially around the river, are all fishing and farming communities. And so most folks are both fishing and farming. So they do both, and they're just dependent on the river. The Mekong fisheries are highly diverse and considered the world's largest inland fisheries. And the Mekong River is made up of mostly, about half of the species are migratory fishes. And so over 71% of the lower Mekong River Basin, which is basically, south of like Myanmar and China, is the lower Mekong River Basin, is 71% is made up of migratory species. And so the kind of open flow of the river is super important for these fishes and for these folks' livelihoods. So what we anticipate for this region is kind of not dissimilar to Wisconsin and Minnesota, the upper Midwest, shifting precipitation, increased variability, increased temperature, and change in season. So in a very different way to here, we experience seasonality like summer, fall, winter, spring. There, it's all tied to water. So it's tropical, but they have a rainy season, a wet season, and a dry season. And the water level in the river in the wet season is driven by rainfall, and water goes up, and that's predictable and has been for hundreds, thousands of years. And then in the dry season, it declines, there's no rain, and water level goes way down. But with dams and climate change, that predictability of wet season, dry season has kind of disappeared, and water levels are just all over the place. And there's they're losing that kind of annual variation and flow, and it's kind of just a constant. There's too much water in the dry season. There's sometimes not enough water in the wet season. And so folks are just dealing with a lot of drought and flooding issues. So overall, the change in the Mekong River Basin, the combination of hydropower development, the shifting precipitation, increased temperatures, and the change in seasonality has resulted, especially in the past 10-ish years, overall in the region, in a mass decline of fish productivity and diversity. And in the region I'm going to talk about today, which is the Northeast region. So to just go back, it's like right here is where I was hanging out for a month, which is about 400 kilometers downstream from the nearest dam, which is about, like up here in Laos, China, or Laos, has experienced about an 80% decline in fish catch just in the past 3 years. So these impacts are like really intense and really recent. So to do this work, we worked with the U.S. Embassy. We ran some workshops. I was there for a month and did basically hung out with a bunch of community members and just had conversations. But we brought over and are trying to apply a climate adaptation framework and introduce this to Thai government officials and agencies to try to start thinking about alternatives in their decision-making process. And so I want to introduce the RAD, so the Resist, Accept, Direct Adaptation Framework, which is a adaptation framework put together by a bunch of US agency groups. Some folks from the casks have been a part of that. That kind of emphasizes that we know ecosystems are changing, whether that's because of hydropower, climate change, land use change, all of these different factors. And so our old management approaches likely will not work for these ecosystem changes. And so how can we support management for changing systems? We may need to start to think about that a little bit differently. And so the RAD approach presents kind of the entire decision space and breaks out decisions into resistance, acceptance, and direct approaches. And then you can understand when you understand the RAD decision space, you can scope appropriate actions. And so, and the appropriate actions are kind of balance the receptivity of change in the society and receptivity of change in the ecosystem. And so then you can start to think about how receptive, if a society is super excited about accepting change, but the ecosystem just like is flat out cannot change at all anymore. We may be down here in this quadrant, and we may just be at the coping level. And so we may need to start thinking about strategies to cope and work towards that. So it kind of presents this decision framework to scope appropriate action. So this was the one main objective of this project, was to work with Thai government officials and agencies to provide guidance in their decision-making process in the future. So I was there for a month, and over the course of that, I had many discussions with many folks that involved discussions with community members, running kind of some more formalized workshops where we introduced the RAD framework, as well as just kind of talked about the impacts folks were feeling and the options they're already implementing, as well as what they would want to see, as well as then working with some more kind of higher up governmental officials. This was the governor for the province we are working in, and all of the agencies that province oversees. So kind of a interjurisdictional project. So today I'm just going to highlight some of the impacts that folks talked to me about, and really just at a course level, and then talk about some of the options that folks are already implementing, as well as where we're going to go with this. So over the course of my time there were tons and tons of impacts that people talked about. And to kind of break it out, some were focused on the ecology, specifically this kai tree, which is a kind of shrub that grows year round in the river system, has kind of just declined extensively. It provides fish habitat. It prevents erosion and from the river system. And so it's with these shifting water levels and sedimentation from shifting water levels, flooding, dam, water releases, all of this, it has really declined, and it's a culturally important species and super important ecologically. Fish, as I mentioned, have just completely, well, not completely, but 80% have just has just completely declined. So this is a fisherman who was showing me a net that he was saying that he doesn't use any, like basically doesn't use anymore because there's no fish to catch. I was fortunate enough to go to Nong Khai, the city I was closest to, had an aquarium, freshwater fish aquarium, where they had a lot of Mekong River fish, which was wonderful to see. But that was a little bit sad to me as well, because that's one of the only places you can see many of these species at this point, because they are critically endangered and just gone within the past 3 years. From a hydrologic perspective, impacts are super dramatic from these unpredictable water levels. There's mass shoreline erosion happening, and there's landslides that just kind of happen overnight, and that washes away houses, farms. Many people farm just on the shoreline of the river, and has some really dramatic impacts on these communities. Also, from a hydrologic perspective, sediment is a key concern from folks. So the dams hold back the heavy sediments, release the lighter sediments, and that just changes the hydrology of the river system completely. For example, this is from a river, from a tributary, or from a village tributary. One day there was a flood, obviously very dramatic. But there's very little kind of buffering along the shorelines for this community. And then less than 2 weeks later, like all the water's gone, everything's washed, all the sediment is just washed away. The shoreline is just like completely gone. People live like right, it's kind of hard to see here, but live like right on those shorelines. And so there's just very little resiliency built into these communities at this point. So thinking about ways we can increase resiliency to flooding and sedimentation effects seems to be a high priority. Impacts on livelihoods has been massive. Folks have abandoned fishing kind of as a livelihood in the past couple of years because it is not lucrative. And so they've just abandoned fishing gear and plants and on their boats and stuff, and transition to really relying on rubber tree farming, shown there, which is relatively new in that space. It's rubber trees are not really native to Northeast Thailand, or they're definitely not native to Northeast Thailand, but they were brought in about 20 years ago and have also contributed to some of these changes because they have dramatically shifted the land use and really take up a lot of water and dry out soils, and also are kind of interacting with all of these other drivers to cause change. And from a contamination standpoint, rubber farming is resulting in a lot of sickness in these communities. So I think from some of the governmental agencies' perspective, when we think about alternative livelihoods, rubber farming is thought of as a sustainable alternative, I think we need to think a little bit broader than that. Something that folks talked a lot about as being basically equal in impact to hydrology and ecology impacts is the impact this has all had on culture. And so a major thing has been with the decline in fish and fishing livelihoods, that younger generations are losing their connection to fishing and fish, and that knowledge transfer isn't happening. And so that culture and the culture around the connection to the river and fishing is just being lost completely. And so there's a lot of work in these communities to kind of integrate advocacy against dams and stuff like that into community events. But it is certainly a challenge. And then many folks have talked about how like local foods, like local freshwater-based fish foods, are disappearing because folks can't catch those foods. And if they catch a freshwater fish, they sell it because it provides more income. And then they use that money to buy cheaper foods like mackerel from the sea. So there's just a lot of shifting dynamics happening culturally as well. So kind of important to think about, at least for me, and as we think about adaptation options, the integration of culture into these adaptation options. So these communities seem to be extremely adaptable, which from the literature is not necessarily surprising given their livelihoods are already super diverse. They do tons of different things between different farming practices as well as fishing. And so these changes, as I mentioned, at least for these communities, they've really started to experience them in the past 3 years, and they've already started to make changes. So here I'm showing the establishment of these community organized fish conservation areas in the river that are self-organized, self-enforced, mostly enforced through the kind of alignment with religious areas. So a fish conservation area is close to a temple. These are Buddhist communities, so folks don't want to commit sins near temples and that by illegally harvesting fish, and therefore they set up conservation areas there. And as well as some kind of community ponds for as a stable water source and fish aquaculture. So as we think about expanding options, not all communities had ponds. So that's kind of a simple, tangible one to expand that out, as well as supporting and expanding fish conservation areas. There's a lot more options, but I only have a little bit of time. And then thinking a little bit more, the government is already doing a lot of shoreline bank enhancement, but it's not necessarily, they're budget limited and they're not necessarily doing it with kind of nature-based solutions in mind. So it's starting to think about solutions that integrate natural practices, I think will be important. There are some low-head dams on tributaries that do not incorporate fish passage. So that has really added to kind of localized fish declines in migratory areas or spawning areas for fish. So working with folks who are expert, there are a couple folks out there who are experts in fish passage for Southeast Asian low-head dams. And so we're trying to bring them into the future to kind of tangibly implement some options for these communities. And this picture here is showing, not poorly showing, rapids in this one area of the river that is unique to these communities, where folks have already started to shift towards more tourist-oriented livelihoods, where they can raft down these rapids during certain times of the year, but they've received very little support from kind of governmental agencies to get those types of initiatives going. So how can we better support that? There's tons and tons of local knowledge already available within these communities. I'm showing this document here in Thai where these community members have already documented the name, location, impacts, both in like financial terms as well as like qualitative terms. So synthesizing, bringing together those local knowledge sources and kind of bringing it to policymakers seems like a good next step as well. And then during my time there, I was able to work with some collaborators from a couple of universities in Thailand who were working with a religious leader as well as a filmmaker from Japan who was developing a film on the cultural connection to the river for these communities and for this kind of region. And so thinking about broadly integrating culture and religion into all of these options, I think will be critically important. And I had a lot of fun. Most of my time there was just hanging out with people and trying to learn. So it's field work, I think, can look very, very different wherever you go. Okay, so today I talked about 3 different projects that span kind of the range of or a range of different approaches. One is a little bit more experimental, theoretical, quantitative oriented. One is qualitative co-production oriented, focusing on collaboration with tribal nations. And then one is really participatory and kind of also co-production, but focusing on kind of participatory active research with Mekong River basins, but all working towards kind of adapting these inland fisheries that are all very different, all different user groups with different objectives, different needs towards resiliency in a changing climate. So just want to emphasize inland fisheries are diverse, they're changing, they support tons of users. Beth Neibauer led a paper put out this year that highlighted kind of the fuzzy boundary between, this image comes from that paper, the fuzzy boundary between fishing kind of for food, fishing for recreation, and kind of how specifically recreational fisheries are on this fuzzy boundary, and many inland fisheries are recreational fisheries. And so I think it highlights nicely how inland fisheries support these many different user groups that have different objectives. And so when we think about adaptation, for me personally, I focus on a few things. One is community partnership, integrating technical expertise, so fish knowledge, ecology, and then integrating adaptation frameworks. So that resist, accept, direct framework to really think about fish, people, place, and adaptation, and how we can bring all of those factors together to increase resiliency. Okay, that is what I have. So thank you all for listening. If you have any questions, please let me know. I am part of, I want to again plug the Midwest Cask, which is hosted out of UMN. So I'm from Madison, Wisconsin, but I come up here somewhat regularly. So yeah, thank you.
I know it's only a few of us. So I'll bring my laptop.
Thank you for the presentation. Thinking about the Name, the lake sturgeon. There historically there was some big hits on the population for harvesting and whatnot. In recent times, is the population still in decline, or is it stable but limited geographically?
Yeah,
it's thinking about, you know, newer climate impacts on either a declining population or kind of a steady population.
It's pretty much, well, from the folks I've spoken to, from my understanding, it's pretty much steady. It's just extremely limited relative to historical. So it's no longer, in most places, it's no longer steadily declining. It is just really low relative to historical. Yeah.
I would think that would help restoration efforts.
It helps restoration efforts, certainly, because then you're not dealing with the declines, the factors impacting declines now are more closely tied to like climate change. Overharvest is not a factor anymore. It's the historical kind of impacts of overharvest where they just crash populations, and then now we're dealing with limited historical or limited ranges due to kind of dams still in place, and then climate changes.
But like that. Steady populations for the most part in those limited
areas. Yeah, there's some places that never recover. So there's a lot of locations that have never recovered, but in places that do have populations, they seem to be relatively steady, but there are some places that, especially with climate change, are starting to experience kind of new declines. So they've kind of held steady for like, I don't know, past recent history, and then it's kind of stabilized after mass declines, and then are now starting to decline again. Oh, yeah.
So for the walleye, when you remove all of like the warm water fish, did you just do that in one lake? Or
yes, Olivia was a huge part of that too.
Oh, okay.
So experimentally, we had an experimental lake where we removed all those fish, and then we had a reference lake that we monitored in this experimental design.
And then results of that?
Yeah, so walleye didn't respond. I mean, the reason walleye are like relative, I mean, they're not long-lived relative to lake sturgeon, but they are a later maturing species. So in northern Wisconsin, they take 4 to 5 years to mature. And then So the kind of time frame of that experiment, we started removing in 2018 and then stopped removing in 2021. So 4 years of removal. And then as of that point, while I had not responded, there was no change. Yellow perch, another cool water species, really boomed. So much faster response, seemed to be more resiliency there, more flexibility potentially associated with biotic interactions, but because that didn't happen in the reference system. So yeah, now we're at the stage where we stopped the removals and we're kind of trying to see longer time frame if we can see those impacts play out.
Awesome.
Yeah.
I have a theoretical question.
Absolutely.
Do you think because McDermott is so shallow, do you think it would, like, in comparison to say, like, not that it's feasible to do on Trout, but for instance, like Escanaba, do you
Well, yeah,
think like it would have responded better if it would have been deeper? Do
absolutely.
you think so?
Absolutely. I think
Yeah.
kind of in the initial phase of the Bright Spots project that we're starting to learn that the walleye do much better if they have deeper, colder water in lakes or a riverine input or something like that. So if we had selected a, but that's also, there's so many
Yeah, I know it was a lot.
collinearities there too, because those types of systems also usually have fewer warm water species. And so it's kind of challenging to disentangle those factors. So yeah, I think there's a few here. I don't know. Oh, those are just thank yous. So
Yeah.
okay, cool. Anything else? I don't think there's any questions in the chat. So that's just still a thank you. Yeah.
How long are you going to continue looking at those?
Monitoring.
Yeah.
So that'll continue. We did this year, I think 4 more years. We will, well, yeah. It's always a question, but I'm going to push so hard to keep it going for at least 4 more years. At least I don't think, I mean, the level of monitoring kind of goes down.
Yeah.
Every relatively speaking, but a course level of monitoring,
Right.
I want to continue for 4 years. Yeah.
Yeah, it could be interesting. I don't know if I stand it, but
There's a question here in the chat that was, is there a political conflict between the countries around the Mekong, particularly in countries that are downstream and don't have large hydro projects? Yeah, really good question. And yes, absolutely. There's tons of political conflict in that area. And absolutely countries that, even within countries that have hydro projects, there's conflict within the country. So like Thailand doesn't have main stem projects, but they have some tributary dam projects. And there's tons and tons of conflict within the country about whether about dams in general and whether that should continue. Well, yeah, none of the communities want it to continue. The government wants potentially power. Thailand's kind of an interesting situation. They have an excess power supply, but then they buy power and sell it. So it's kind of a commodity trading situation. So the hydropower thing, and then upstream countries like China and Laos use the power to, Laos especially uses it as a commodity to trade. So yeah, and then China uses it to trade as well as fuel themselves with electricity. But yeah, there are so many political dynamics to the situation around the Mekong that it presents a lot of challenges for any a kind of change, large scale change to happen. But I think that's why we're trying to take a really localized approach, as well as then like what I presented here were kind of the really tangible localized options recommendations, but then we have a lot of other recommendations that are more generalized and scaled up, I guess. And then one other question, I think, and then we're probably out of time, but were certain communities more eager to help than others? I don't know if that is in reference to the Mekong project or the Lake Sturgeon project, but I'll talk about both. So for the Mekong project, everyone was especially keen. They were super keen to help, or to engage, I should say, because I think this region we were engaging with because they had they felt they had been overlooked geopolitically from the Thai government. Like all of it, their region, they had just felt really overlooked. So they were excited to have a voice, basically. For the Lake Sturgeon project, yes, certainly some folks have been more eager to engage than others. I think a lot of that has been dependent on folks' capacity. It's just like everyone is stretched really, really thin. And so whether folks have capacity to engage is understandably limited. So yeah. With that, I think probably there's no other questions. So
Okay.
probably, yeah.
Cool. Yeah.
Yeah.